Yeah, he's very cool. It's funny. Okay, so right, so multi-threading. We're just going to go over what threads are, what these classes mean, the runnable and threads class, and the platform run later, and so on. And what does it mean by synchronizing a thread and the life cycle of a thread? Okay, so let's look at some of these terminologies here. So we talk about thread, you talk about these three things here. Okay, the application, the process, and a thread. So the application is just basically the application that you write, like whatever the application may be. Okay, a process is the instance of that application, and again, some of these are just like a concept, but the idea behind a process is that if you think back to, well, the computer itself, you have some nowadays most computers have 4 processors, right? 4 CPUs or quad core. You see it all the time when you go buy your shop floor computer. Back in the early 80s and 90s, we didn't have that option. It's just one processor, one CPU, and for a single CPU to process data, it could be very tedious, and it takes a lot of effort to do that as well. So it wasn't able to process so much data because it's limited by the processor. But when you have different ways of how they could do that is to create threads. Okay, threads is basically it's a sub part of a processor to do a certain task that is run inside a process. Okay, so if you think of a process as an application, then inside the application you have threads, the tiny sub parts of the application that can run concurrently and independently to process some data. If you think of like a database or an array of a list of, let's say, 1 million or maybe 100 million records. Okay, imagine you have a single process to run that data. It could take a while to do that. So to make things run faster and better, you would split that array or that database or that data into chunks of smaller pieces. And by doing that, you would delegate each thread to do a certain task. So you can break it down to, let's say, maybe 1,000 thread or 100 threads, and each will process 1 million records, and the other one will do the other million. So when they're all done, you actually shorten the time span to complete that process. Okay, so that's the whole idea of creating threads. So a thread is the smallest executable unit. It's actually just a flow of execution of part of a program. So there are 2 main types of threads. You have the user thread. This is something that you can create yourself, and you have something called the daemon thread. This is part of the JVM. Most languages have these already built into it. These are like threads that or executions that run in the background. Like, for example, when you print something under your Microsoft Word, right? You can type at the same time while it's sending data to the printer. You can save it. You can copy, paste. You do all those at the same time simultaneously. That's because of threads. Okay, without thread, you can't do that. You have to do one process at a time. So imagine you send something to the printer, and there are some applications still do that. You send to a printer, you have to wait until it finishes printing, and then you can continue to the next execution. Okay, that's a single thread. With multi-threading, then you eliminate that issue. Okay, so you have 2 types of threads: the user thread and daemon thread. So the thread class is a class that is built into Java, and it looks, again, just this diagram I think we saw last time, kind of depict what a thread will look like. So you have your program here, and inside the program you have processes, and inside the process you can have multiple threads, okay, to run certain tasks. And I'll show you in a minute here what the threads have in common. So the concept of a thread here again is, if you look at these diagrams here, the diagram A has like 3 threads, and then these gray boxes are your CPUs. Okay, you can see that each CPU has a thread for A, so they can run a single thread or multiple threads on a single CPU, right? In part B, you see that you have 3 threads. but then you have a single CPU that is shared across all those 3 threads. Okay, and so part A is very dedicated because all the threads are dedicated to one storage CPU. If it's really busy, then it does the whole task by itself, which is fast, right? And part B is that also you are sharing that CPU with other threads, other tasks, because if you don't share the CPU, then maybe CPU is just waiting, sitting idle. It doesn't do anything, just wasting time. So instead of having to wait, you could allocate its time to process other data. So you can issue allocate some of those time to these threads, and they can share that CPU time to process data. Okay, otherwise, just waiting and it just doesn't do anything. Okay, so you use thread to take advantage of the multiprocessor systems. Again, if you have your laptop, most computers today have 4 processors, 4 CPUs. Some have more. Okay, the more you have, the better. But it doesn't mean that it's always better, because depending on the application too, right? So if you have a CPU system and your applications don't use them all, then it doesn't really make a lot of difference. Okay. You use it to simplify modeling, again to split tasks pretty much, for make the user interface more responsive, like your JavaFX, the Swing. You have the responsive, event-driven applications. So when you run your JavaFX, it just waits there on the screen waiting for you to do something, right? So when that's happening, you really just wasting CPU time. So when that happens, you should allocate a CPU allocated so it will do something else besides that. And also for asynchronous and background processing, like we showed the example last week about the client-server communications, that needs a thread, right? So you can have a thread that can communicate with the server, and you can have multiple threads to do that as well. So you can have multiple users log into the server, so you have this communication going on. Okay, and there are a lot more, but these are mainly the 4 major reasons. So some characteristics of threads, that they are independent of each other, that's for sure. Okay, it's like how you have a class, right? A class is a template, and when you instantiate an object out of a class, that object is completely independent of each other, right? So you can instantiate 2 or 3 or n number of objects out of the class, and each of those is completely independent. So a thread is kind of similar to in that nature, but they also share a lot of things in common too. Okay, so in a thread you have they have their own stack. Okay, the stack is here I put thread specific. I'll explain what that means in a bit. It has its own counter. It has its own local variables. Okay, these are things that are independent of the threads. It's like a tiny program itself. Okay, but at the same time they also share some common things like the memory space. Okay, if you look at this diagram up here, okay, so here's the process. The process is in a special space in the CPU, has a memory address. So these threads are a part of that CPU, that process, so they share the same memory location. Okay, so the same memory address. Okay, so because of that, then they have some things in common that they can share. Things like file handles, like when they open the files, the other thread can also access it too. Okay, and also the heap. Again, the heap is an application specific. Heap is just basically just a memory and RAM as something with stack. Okay, different types of memory. And one of the things I guess is very common in threads is they share the process state here. Okay, the state is the actual variables, the objects, and their values. So if you think about back to like the account example, you have a bank account. That is the total of the main account that has some value, some money in there, and you can split that account to some smaller accounts. Okay, so those smaller accounts can withdraw or add money to the main account. Okay, so each of those threads can access the main account. If they make changes to that account, you see the number will change, right? So they share that state. Okay, if you make changes to a variable, then other threads can see it too. It will also affect them. It's like a static variable, right? if you change a static variable, it would affect all the other objects and everywhere else. So put a caution here, because they share the same information with each other, they can coexist in the same memory space, right? It's really important when you code threads, because they can interfere with one another. So if you think about, like in databases, you can have these different threads, and one is actually changing the value of one variable name, the other one is trying to grab that same variable data, and you have a different number. Or maybe you can overwrite each other's data, right? Same idea with the threads here. This is also why this is also a really important issue in databases, to make sure that they don't write each other's data. Okay, otherwise you have data integrity issues. Okay. Threads also have names. Okay. Here just a little example. Here you can use the set name and get name methods to assign names to threads. So typically, this is how you would create a thread. Okay. Thread. This is a thread class T1, just a variable name, and then new thread. So it's very common. Just basically just instantiating the object same way, and then if you want to give it a name, you say T1.setName is the my thread or something. If you want to read the name back, you can say get name. Okay, it's not really widely used, this part, but you can, especially if you create a lot of threads. You want to know which thread does which data or which activity, so you can keep track of those. But every program in Java has at least one thread, which is the main thread. Okay, you may not have noticed it, but because we haven't talked about it, you have already used thread since day one when you learn Java. When you write that very first Java program, it is running this main thread. Okay, so without this main thread, you cannot have a Java program running. Okay, in addition to the main thread, you also have some other threads running in the background. These are what we just mentioned about the daemon threads. These are like, you have the garbage collection threads. Okay, it cleans up your memory. The memory, when you, let's say, created a variable name, if you don't use it anymore, you stop using it, it actually collects it, and then restore the memory back to the RAM, so you can use it again. So you have that garbage collection. Another is the object finalization. This is like, these are kind of advanced stuff, but before you actually delete that data from memory, it needs to do some cleanup stuff behind the scene. Okay, and a few other stuff. So I just want to explain a little bit about the stack and the heap, so you can get an understanding of what they are, because these are things that will actually turn up again and again in the future if you hear about stack and heap, especially if you go into computer science. Okay, so if you look at this code here, okay, this is really common stuff, right? I have a class called course, and then I have a class called student, and this is the main program because it has a static void main, right? Inside the main, you have a string class, string array of arguments, args, and I will create an instant, a local variable called num and a pass, and I have a string message assigned with that value here, and then I have a course object, which is this one here, right? New course. I have another student one object of the same class here called new student, and I call display because this is a method inside the student class. I display that, I pass the course to it, and then you would do something inside there, right? Typical application. So when you run this application, when you execute it, JVM will create a main thread that will look for this main method and will execute the code. You don't see it because it happens behind the scene. Okay, you can pause the thread, you can stop it, also, or you can put it to sleep. That's the term as well. But it runs this whole program, and it will end when it reaches the end of that public method called main. Right? It will stop after it prints out this, and then there's no more line of code. It stops execution. The thread is stopped, and then it terminates and ends the program. Okay. So the ones I put in red here and in blue are I'm showing you the type of memory they are stored in RAM. You have the stack memory, you have the heap memory. Okay, stack memory are like usually refers to your the primitive data types. So if you have anything with int, Boolean, double, okay, all these are primitive data types. and they are stored inside the stack memory. Anything that is part of a class, like string is a class because it's a capital S, right? By convention, we use class names in the capital S. So a string you've used all this time is actually an object. It's not a primitive data type. Okay, if you try a lowercase s, it won't work in Java. So that's why message is actually an object. And same thing with course, because that's the one we create. Same thing with student. So, and here string is again an object. So you can see if you put into the list here, starting from the bottom up. Okay, on this side. The reason I say that because if you think about a stack, what does a stack do? If you think about a stack of dishes, right? The stack always go with this thing here. I should have put something here. LIFO here. Okay? LIFO means like, what's LIFO means? Anybody know? I'm sure you heard it before, right? LIFO. Let me just go back up here. LIFO means why doesn't it stop there? Just do this. Okay. LIFO means last in, first out, right? That's LIFO. So that means if you stack a plate first, that's going to come out last. So whatever is stacked last is going to come off first, right? So LIFO. Yeah, the other term for that is FIFO, right? FIFO. This is first in, first out. And this is what is used in a queue. Okay? UE. If you think of a line in the bank, you go in line first, you get served first. Okay? Whereas a stack, you get served last. So if you look at this here, you have the blue here, the gray here is the stack memory and RAM. This is other memory called the heap. Okay, this heap here is shared by all the other threads. Okay, the stack is shared by a single thread, so you have its own stack memory. And so if you look at the main here, this is the main program, so you have a main thread. So you stack that first, right? You run the main program first. After that, I have an argument. The argument here is red, so argument is the second variable. The first variable it creates. It's part of the heap because it's a class object, but it's still so that is just a reference to the actual memory address. So where it's stored in memory is in the heap area. Okay, it's just two different memory locations in RAM. So to get this actual data, you have to reference it using the arguments or the string message or the S1 or the course C here to get the actual data from the heap. So in this sense, these memory in the heap are actually much slower to access than the ones in the stack here. Okay, these are instant available. So the only ones you see here are the one in blues, which is the int num, the boolean pass here, and then the int I, because I is inside the for loop, right? So every variable you create will either be pushed to the stack or the heap. Okay? So all primitive data types are in the stack. And the first last in, first out here, if you think about a function, right? So for example here, you call the main function. The main function here calls the display function. The display maybe in here may call another function. Okay? So in here, I might have some code in here. After the for loop, I might do some additional statements in here, right? Whatever this is. And after I call that display, I might do some more stuff in here, right? So these don't get called until this is done, right? Is that true? So you call here, you go in here, you follow through, and these are done. If I call another method, if there are any codes after that, they have to wait until the other one's done. It comes back. So if you put this in the stack, you put the dish first, and you put another plate. You put another plate in here. When this is done, it comes back out, and then you go back the stack. That's how you push it down to the bottom. All these guys here have to wait until this guy is done. So you have to wait on the stack, okay? In that scenario. So I just wanted to show you what they mean when we say stack and heap. If you ever go into computer science degree, you will run into this again. Okay, so these are all like object space, and these are just pretty much really simple primitive data type. Okay, let's go to the life cycle of a thread, and there are 5 thread states. Actually, there are 6 of them, but they're mainly the 5 of the main thread states. State means like when you create a thread, it runs into this phases, right? You have different phases. So when you start it, it has a new state, and then it will go into the ready state, and the ready state, it will either it will go and run, ready for run that thread. It can also be, turn back to the ready state if it doesn't have anything to run, so you can go in this cycle. Or it can just basically go and end that thread, right? You just finished it because there's nothing to run. Or you can go into a wait mode. Down here you have 3 different waits here: the join, the sleep, and the wait here. Okay, so you have the you can wait for to be notified, because if you put it to a sleep, it will just sit there and wait until it gets notified. You say, hey, don't sleep anymore, do your job, right? You have to interrupt it to do its work. Otherwise, you just wait there. Okay. Join means that if you have multiple threads running at the same time, you want to wait until all the threads are completed when they're done with the job, and then they join together, and then you would process the data all at once. Okay. If you don't join it, that means one runs, it will end, and the other guys are still running. And so when you do that, some of the data may not be correctly rendered. Okay. So this is different types of methods you can issue to a thread. But 5 steps: the new, ready, running, the blocked, and then the finished state here. So again, just some information here to show what those are. And yeah, so this is a little piece of code. You can run this, and it will show you those 6 different states and that for each thread. But I want to go into right here into the different ways how you can create threads in Java. And there are 2 ways how you can create threads in Java. Okay, one is you would extend the thread class. The other is you implement the interface called Runnable. Okay, it's these 2 different classes you can use to create threads, and each one different depending on which one you use. You have a little bit different in the syntax. So the Runnable is actually a parent class of the thread class. So in the Runnable class, or the interface, has only one method called run. Okay, that's all it has. It just has the one single method called run. So if you remember, we talked about like way back in chapter 13, right? About abstract classes and interfaces. Okay, so we implement an interface. You have to implement all the methods in there. It's required. Okay, and the threads class, it has many more methods, but one of them is also has a run method too. And you are not required to implement it, but you are able to override it as well. So you can override a method to do certain tasks. Okay, so the Runnable interface will look something like this. So you have you can create a class called the task class. Okay, and to extend the Runnable, what we call the implements. Okay, when you see the word implements here, I mean this is an interface, and then if you have the extends keyword, that's a class. Okay, so he implements the Runnable here again. So inside this class called task class, you have to implement the run method. It's a void, so just do something, whether it's empty or not, it doesn't matter. You have to implement it. And once you create this class called task class, then in your main program over here, we call the client, and you can now create a task called task, and then you add that to the thread. Okay, and then the thread will create the task, and it will run it. Okay, I'll show you how these work in a bit here, but it will look very similar to this same syntax here. So you can create a class called whatever you want, run project, update database, what doesn't matter, what you call it, maybe display survey, right? There you go. And it would do the task for you. And so this thread called thread here can run that task, okay? So you create the instance of that, you add it, you push it to the thread because the thread needs a variable parameter called the runnable type task, and then you do it the dot start to start the thread. Right? So this is the runnable, and then the thread class. As you can see, the thread class is a subclass of the runnable interface. So it actually implements the interface called runnable. And inside the thread class, you have a lot of methods. Actually, there are a few more than these. But what you don't see here is a run method, which is also in here because you have to implement the runnable, right? So the thread class has to do it, but you can override it. So here's a start method to start your thread. A join, just a sleep, you can put a sleep, and so on. Okay, so to create a thread in there, you basically create a class called thread1, if you want to call it that. And then you will extend the thread class, and then again here you would override the public void run method, and then in here this is where you do your task. Okay, and then your main program, so inside the void main, for example, then you can create a thread1. This is your class you created called t1, and then create a new thread. This actually should be a thread1, sorry, should be that. And you instantiate a thread called t1, and then now you can say t1.start, right? Because I don't have start in here, but in the thread class has a start method. So that's why you can call the parents method directly from the child class. Okay. So when you click and run this application, it will look for the start method inside the thread class, and then that start method will actually run the run method. So you're not going to say t1.run. Okay, you don't want to do that. And the reason why you don't do that is because if you do it, then this thread is actually not running, but it will actually running from the main thread to run this method here. I know it's a little bit complicated, but you always just issue the start method to run your thread. Okay. So kind of similar here, as you can see, I have the thread extends the thread class. I have a custom constructor, the run method. I do some tasking here, like print something or do whatever it needs to be done, and that's all it does. Okay, and then on the main program, I create a new thread called thread1, instantiate that, and then start it. I can create another thread called thread2, and then it will do its own job as well. So both of these threads are part of the same class here, so they will do the same thing, except each one does its own job separately. Okay. And you can have, thread 3 and do the same thing, and so on. So I just kind of showed this already, how you implement the runnable. And then here you have the you can define your threads in different ways. Use separate concrete class. The inner class, I'm not sure if you remember this anymore, you can create another class inside another class. Okay, you can do that as well. You can also have the anonymous inner class, which we used before to create our lambda expressions, right? The same way. And there are many others as well. You have the local inner class, which means you can actually create another class inside your main method too. You can do all those cool stuff with Java. Okay, so here is an example of the anonymous class. So here's a thread, and this is the one that actually used in the book, if you remember from last week's. So you have a thread, new thread, and then you have the new runnable, and then inside here you have you actually instantiate a new runnable object, and it runs inside here, and then the dot start is to run that thread. This thread has no name, so it just runs one time, and it would end when it finishes its task in here, whatever you put in here. This is thread 2 using the lambda expression. So notice here I'm not using the new runnable, I just say, I put a paren here and then the arrow, and then inside here just put the task. So I don't have to put the run here. It automatically knows that it's running that run method. Okay, so the lambda expression, lambda is really powerful and also shortens your code so much since Java 8. Okay, so, and multi-threading is, I just showed you how you can create multi-threading. So the single thread is again the main thread. So for example, you run this application, it prints, right? You just print, you know, for I is 1 to 100, you print it out. This is a thread. We never talked about it, but that's a thread. It's run by the main thread. And this is default thread. And then with this main thread, you can create other threads. So you can have multiple threads, right? So inside here, you have a thread called thread 1. We just kind of showed that a little bit earlier. Prints a number between 0 and 1,000. And then you have a second class called thread 2. And then that's also print between 1,001 to 2,000. Okay, so you have two classes. And then inside your main program here, then you can instantiate the thread 1 to run its job, calling the thread 1 class. And then thread 2 runs its job in the thread 2 class. So thread 1 prints, you know, 0 to 1,000, and thread 2 prints, you know, 1,001 to 2,000. And this will run together concurrently. Okay, so in other words, this one doesn't have to wait until this one is done. Whereas if it's not a thread, then this will get prints first, after it prints all the 1,000 numbers, and then this will run, right? That's a sequential way of running in the single thread. But because there are two threads, they're independent of each other, and when you start it happens so fast within like 0.01 milliseconds. You can't even tell they run together at the same time. Okay, and it will be really difficult to see it unless you put it you pause it for a second or two. And you can see each does its job separately, but concurrently. Okay, and then you can put it to sleep. You can pause it, and you can also join it so they can wait for one another, right? So for example, here this thread will print something. If it's done already, it can wait until the other thread is completed, and then it will both will be done, and they'll join together, and then you print the results out.
I'm gonna go eat.
Okay. Right.
Have a good class.
Right. You too. Thank you.
See you later.
Bye. And then because threads can run at the same time, right? Sometimes they can have they can get locked up. If again, this is similar to databases. If you haven't taken databases yet, so when they are locked up, means that one thread is waiting for the other. So you keep waiting each other, and then they never finish waiting, and so they'll run into an infinite loop, and then they'll crash the system. Okay, because they share the same data. So what that means is that when thread 1 is working on object 2, and now it's working on object 1 currently, but it wants to get object 2, and thread 2 is working on object 2, it's holding that, and it wants to access object 1, but it's waiting until object 1 is released from thread 1, and thread 1 wants to do that because it's waiting until thread 2 is released from object 2. So they don't release each of those objects, and then you just keep waiting, and then it'll just go forever. So we have a deadlock. Okay, this is similar in a database as well. You have two lots locking each other up, and then you're waiting. You want to write data, the other one's waiting for the other data to write, and you just keep waiting each other, and you end up with an infinite a loop there, and then you just crash the system. So this is one of the dangers that happens when you write threads. Okay, synchronization here is, it means like when you have this kind of problem here, you don't want to do this. So what you should do is you should synchronize them so that one thread runs this object. When it's done, it should release it so the other one can run it. Okay, you don't want to keep it waiting there. So you synchronize it as well. At the same time, because they share the same data, so that means, you know, thread 1 can change thread 1's, thread 2's data, and so on, because they share the same data. So you want to synchronize it so that only one thread can update the data at any given time. so you get the correct data. Otherwise, they would get different data, and then that's you can lead to incorrect results. Okay, so with all that said, I'm going to go into Java and just do some little demos to see how threads work. Okay, it's right in here.